In this section here, we're going to be talking about reducing rational expressions to lowest terms. Now, this is going to be a little bit of an overlap of the previous section on rational expressions with integer coefficients, and I did work a lot of examples, and we simplified the rational expression down, and that's pretty much what we're going to do here. So let's just go through, and if you haven't seen this, we're going to refresh your memory from the previous section. Let's say, I guess first off I should say that a rational expression, a rational number, okay, is a fraction, like 3/4, 7/8, negative 2/3, whatever. Um, and that's basically what we're working with here, except we have variables involved like x and y's and a's and b's and so forth. But let's just work something simple here, like 8x to the fourth and y squared over 6x y to the third. Alright, so what we want to do here is we want to simplify this down. Now we want to look for the largest number that goes into both 8 and into 6 if possible, and that's going to end up being a 2. So 2 goes into, actually we'll start down here, 2 goes into 8 4 times, and 2 goes into 6 3 times. Now we have 4 x's in the numerator and 1 x in the denominator, so we can cancel one of these x's out. And in the previous section we wrote it like this. We took this up into the numerator, and because this is to the first power, if we take it into the numerator, it's still it's the negative of whatever the power is down here. So take it at the top, then it becomes -1. And then we'll go ahead and do that with this y squared here. Take this into the numerator, and it becomes y to the -3rd. Now the reason we do that is so we can go ahead and add their powers together since these bases are the same. So this is 4 minus 1 is a 3, and 2 minus 3 is a -1. Now we don't ever want to write our answer with negative exponents, and so because this is y to the -1, we can take that down into the denominator. 4x to the third over 3y, and of course I don't write a 1 here. I just assumed to be a 1 here. Okay, so this is kind of what we did in the previous section. Well, it's not really kind of, it's what we did do in the previous section. So let's work another one here. Let's see. We have 3x cubed plus an x squared y, and that's all over x squared y squared minus 2x y cubed. Okay, and so what we're going to do is we're going to, what are we going to do? Let's see, we can pull an x out of the top up here. So you might want to check out the section factoring binomials. This is a binomial we got in this expression up here in the top. We've got two terms here, and they both have x's involved in them. We can pull out an x, and we always pull the one out with the smallest exponent. So I'm going to pull an x squared out. 3, and if I pull 2 of those out, we're only left with 1 there, plus y. Okay. And then in the denominator, we have an x squared, we have an x, we have a y squared. I guess really the only thing we can do here is we can pull an x out. We can also pull out an y. Alright, let's see what we got coming up here. We're going to have 4x cubed y minus 4x squared y, and that's going to be all over 2x y squared minus 2x squared y squared. So we're going to reduce this to lowest terms. So what we want to do is look up here in the numerator. What can we factor out? What's in both this part of the expression and this one over here? It looks like we can pull a 4 out. They both have 4's, and they both have x's, and they both have y's. So we're going to be able to factor out a 4, and we always look at the one with the smallest exponent, an x squared, and the y here has the first power, and this one has the first power, so we'll be able to factor out the y. Okay, and what in the world we're going to have left? Well, I pulled out a 4, 2 x's, and a y, so we're just left with an x, and pulled everything out over there, so we're just going to be left with a 1. Okay, once you pull that out. Now let's look at the denominator. So we have a 2, x squareds, y squareds. Okay, so we're going to be able to factor out a 2. The x squared, so we always pull the one out with the smallest exponent. And a y squared. So I pulled out a 2, an x, and a y squared, this first part of the expression. So we're just left with a 1. And minus, pulled out a 2, 1x, so we're going to have an x left. And pulled out all those y's there. So, okay. Let's I'll tell you what we're going to do first. Let's just go ahead and reduce this first part here, and then I'll show you what we're going to do with that. 2 goes into 4 2 times. We have 1x, we have 2 x's up here, so this x will go into x squared and will be left over with an x. So this is going to be a 2x. Now we have 1 y in the numerator, but we have 2 in the denominator. So once we cancel one of those out, we're still going to be left with 1 down here in the denominator. So we'll just rewrite that right there. Now, here's the trick on this one. I'm going to factor a -1 out of this top piece right here. And so if I were to, and I'll just put it right here. So if I factor a negative out, that becomes -x, and then that will become a +1. Crazy, isn't it? And then over 1 minus x. And so here's the reason I factored this negative out. Now, and that is so I can get it to match the denominator. If you take this -1 and you distribute it back inside, for example, -1 times -x is +x, and -1 times 1, right, is going to be your -1. But what we have now is we have a term in the denominator and the numerator that are both the same. And now I'm going to take this negative and move it out into the front here. So -2x over y. And I'm going to rewrite this piece right here. This is 1 minus x. So it looks just like the denominator. 1 minus x. And of course, this number is the same as the number in the denominator. So you can now cancel those out. And we're just left with a -2x over y. And that's now been simplified completely down. We have reduced all of that down to the -2x over y. Amazing. Alright, reducing rational expressions to lowest terms. Let's take a look at a similar problem. We have 6x squared plus 7x minus 3. And that's going to be all over 4x squared minus 9. Alright, so we want to factor the numerator, factor the denominator, and then cancel out terms. So let's look at this now. Under the section of factoring polynomials, and this actually is a trinomial, it's got 3 terms in it up here in the numerator. I worked quite a few of these problems in that section if you wanted to look at that. Okay, so what I'm going to do here is I'm going to start out with something like this. Alright, we're looking for numbers. Let's see, here's our possibilities. We can use 1 and a 6, or 1 times 6 I should say, to get 6 here, or 2 times 3. And then for this term here, it's either going to be, well, I guess it's just going to be a 1 and a 3. That's about all we have, which is good. And in other words, I can put a 1 here and a 6 here, or a 2 here and a 3 here. And what I'm going to do here is I'm going to go ahead and put a 2x and then a 3x. Okay, that's coming from these numbers here. Alright. And when we multiply these two numbers together, it's got to be negative 3. And so let's see if I can get lucky on this. And I'm going to say this is a 3 and a 1. Alright, that's coming from this here. Now we got to get our signs right. Okay, so 2x times 3x is 6x squared. 2x times 1 is 2x. And then we have a 9x here because this would be 3 times 3x. And 2 and then 9, so we got to think about this. We want to get a 7 here, so this is going to need to be a plus, and then this is going to be a minus. Okay, so right, so think about this when we multiply this out. We have 2x times 3x is 6x squared. 2x times negative 1 is negative 2, and then 3 times 3x is 9x. But we need to get a 7, so 9 minus 2 is 7. Alright, without working this thing completely out. So there you go, I got lucky because we got quite a few combinations over here to work with. And then in the denominator here, this can actually be rewritten as 2x squared minus 3 squared, because 2x squared is 4x squared, and then minus 3x squared. Well, this is a binomial, and it's the difference of two squares. And we can actually factor that as 2x minus 3 times 2x plus 3. And if you haven't seen that before, you need to go into the binomial section, factoring binomials. Alright, so now what we can do is we can cancel some stuff out. We have a 2x plus 3 in the numerator and a 2x plus 3 in the denominator, so we can cancel that out, and we're going to be left with a 3x minus 1 over 2x minus 3, and that's as far as we can go in reducing this down right here. Okay. Okay, so I'm going to write this one up, and it's going to be up to you to work it out. This little quiz here, and then you can pause the video, and then I'll work it out and see if you got the same answer I get. Alright, so like the last problem, I don't know why I'm stuck on 6 there, but we have 6x squared plus 2x minus 4. So you'll want to pause the video and try working this one out. 3x squared plus 7x minus 6 is in the denominator here. Alright, so what we want to do is factor the numerator, factor the denominator, and then cancel out terms. So go down, pause the video, try working this out, and see if you get the same thing I do. Alright, so this is how I'm going to do this. A lot of times it's a trial and error thing when it goes to factoring these things out up here. I'm going to start with a 2x and a 3x. So 2x times 3x is 6x squared. Now two numbers are multiplied together gives us negative 4. Alright, and we're going to add two numbers and we get positive 2 here. I'm going to use a plus 2 and a negative 2. Okay. Okay. So we have, now if you multiply all this out, we should get what's in the numerator up here. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. Let me just do a little side work over here so we don't get lost track. Negative 4x, and then 2 times 3x is 6x. And of course that's going to add to 2x, and that's what we get right here. And then 2 times negative 2 is negative 4. Okay, good. Well, considering we're going to be canceling terms out, right, it should be a clue up here in the numerator that probably what we put in the denominator, one of these guys is going to be in the denominator here, so that helps out. Now I'll tell you what really helps out is when this number right here, the only factors is 1 and 3. 1 times 3 is 3. So I'm going to go ahead and use a 3x. So there's not any other combinations, and that's nice. Whereas up here we had a 1 and a 6 and a 2 and a 3, right? That gives us 6. Alright, and then this number here, of course, it could either be a 1 here and a 6 here, or it could be a 2 and a 3, or you could put a 3 and a 2, or a 6 and a 1. Okay, so, but because we have a 2 up here, chances are it's going to probably be a 2 and a 3. Alright, so that's kind of a hint there. So 3x times 3 is 9x. Remember, we need to get a 7 here, and then a 2x. 2 times x is 2x. A 9x and a 2x. So this is probably going to end up being a, because this is a plus sign, this is going to be plus. And of course that'll be minus because that's what this term is up here, right? Well, now we can cancel some stuff out. Actually, let's check this real quick. So 3x times x is 3x squared. 3x times 3 is 9x. I'll just write that over here. And then negative 2x. Right? And 9 minus 2 is 7. Okay? And then negative 2 times 3 is negative 6, and that's what we have right here. Alright, good. So we'll cancel out the 3x minus 2 and write what we have left over, which is going to end up being a 2x plus 2 over an x plus 3. Alright, so all that up there reduced down to this right here. Great. Alright, well let's work some more. Oh, and by the way, I hope that's the answer you got. So. Alright, we have 2x squared plus 5x and minus 12. And that's going to be all over 9 minus 4x squared. And what we're going to want to do here is reduce this down. So let's factor the numerator. Actually, I think I'm going to rewrite this problem and show you something here. We're going to redo the bottom here. I'm going to rewrite that bottom, but go ahead and copy the top. Minus 12 over. Okay, so this can be rewritten as 3 squared minus 2x quantity squared. Okay, so this is the difference of two squares. Now what I'm going to do here is I'm going to go ahead and factor out a negative out of here. And of course there's always reasons for everything. Let me just go ahead and write it over here. We have 2x squared plus 5x minus 12. Now it doesn't matter whether we work in the numerator or denominator first. It doesn't matter, but I just want to clear this up first. So I'm going to factor out a negative. So we end up with a negative 3 squared, and then this is going to become a plus 2x quantity squared. So we got to fudge this thing to get it to match up with some other stuff later. Now I can rewrite this piece right here. 2x squared plus 5x minus 12 over, pulling that negative out, and I'm going to rewrite this because this is kind of the standard form we've been using earlier, and this is minus 3 squared, the difference of squares here. Okay, let's just leave it at that right now. Now let's go ahead and factor the numerator. Now it's a good thing we only have a 2 here, so this has got to be a 2x. And of course this would just be an x here. Let me actually, maybe we should go ahead and factor that bottom out because it gives us clues of what we're doing here. I have a negative, keeping the negative out here, start of parentheses. So this is the difference of two squares. So this is going to be 2x minus 3 times 2x plus 3. Now you figure that probably one of these terms in the numerator or denominator is going to cancel out. So we're going to have one of these terms, either the 2x minus 3 up here or the 2x plus 3 up here. Okay, so that kind of helps us out, I think, when trying to reduce this down. I'm going to go ahead and write the bottom here. 2x plus 3. Alright, two numbers multiplied together gives us 12. Well, it could be 3 and a 4. But we got to get this right here. So I'm going to put the 3 over here, and the reason for that is because we have 3's in both of these, and we need to get a 2x something plus 3 or minus 3 up here to probably cancel out with the denominator. Alright, see what I'm saying? Okay, and so let's look at this. We have a 2x times 4x is 8x. Let's just do a little side stuff over here. And then 3x. Now remember, we need to get a 5x up here, so this is probably going to be a minus then right here. So that would be a minus 3x here, okay, and then a plus. And now as you can see, we can cancel out, and you can now see what we are going to be left with, and that is an x plus 4 over 2x plus 3, and just bring that negative up here into the denominator and just bring it out right here. Alright, looks good. Alright, we have x cubed minus 64. So when we were factoring binomials, man, that's terrible. It's really difficult to write on a tablet. And I don't mean a writing tablet. Okay. X cubed minus 64, x squared in the denominator, minus 8x plus 16. Yeah, so when we were factoring binomials, bi meaning 2, there's two terms here, we went over the difference of two cubes. There's kind of a formula that you need to follow for that. Alright, and let's just go ahead and factor the numerator. So I'm going to actually let me rewrite. I'm going to rewrite the numerator here. This is x cubed minus 4 cubed. So 4 cubed is 64. Now we have the difference here of 2 cubes. Alright, so it starts out like this. So we write x and then rewrite our sign and rewrite this number here. So that's the reason I get it in this form. Okay, this is the part you got to remember. So it's this number right here squared, whatever this is, and it's always the opposite of this sign. So if this is a minus, then we're going to put a plus here, and we're going to rewrite that number times x, and this is always a plus right here, and it's going to be this number here squared, which is 16. So you could think of this whole piece right here being squared, which is always going to be positive. Alright, so that's the numerator. And now we need to factor the denominator. Well, good thing we only have a 1 right here, coefficient of 1, so this has to be an x. We got no other choice and an x here, so that's good. However, this is 16, and there's a lot of different combinations that can go on with that. But there's a hint up here, there's a 4 right here, so chances are it's probably going to be a 4 because we need to get some terms canceling out here, which means that this has to be a 4 because 4 times 4 is 16, right? And I'm going to say that's a negative, and this is a negative also, okay? Now let's just kind of check it out. X times x is x squared. X times negative 4 is negative 4x, and then another negative 4x, and we add them together, we get negative 8x. And negative 4 times negative 4 is positive 16. Alright, good. And so we have an x minus 4 in the numerator and x minus 4 in the denominator, and so now we can cancel and rewrite, and so this becomes x squared plus 4x plus 16, and that's going to be all over x minus 4. So that has now been reduced completely down. So hopefully you got that. Alright, in this next one here, I'm going to write the problem up and you try to work it out. This is your quiz problem, and then I'm going to write the answer. Actually, I'm not even going to work this problem out. I always forget to do something there. Add a layer. Got to add a layer. 2x squared minus x minus 3, and that's all over x cubed plus x squared plus 4x plus 4. I'm not going to work this problem out, I'm just going to give you the answer. Alright, so you pause and try to come up with the answer. Alright, so there's the answer, and you try to reduce this thing down and factor. Factoring this falls under factoring polynomials, I believe. Alright, good luck.